Okay, in this video I'd like to wrap it all up and actually find my answer. So we said given this differential equation, our formula of the solution is a constant times the power of x. We actually came up with formulas for a bunch of the constants in the last video. Something to point out or something to note about this is we don't actually have a formula for C1 and we don't actually have a formula for C0. Turns out that's not necessarily a bad thing. So let's just see what this gives us. So I'm going to try and plug all these constants into this equation. So first I'm just going to rewrite the equation in a little bit easier way to see. And I always do this because without doing this, it's really easy to make a mistake, like losing off your constant or forgetting your x squared term or something. So a constant Cn times x n would be C0 times x of 0, C1 times x at first, C2 times x squared, and so on. And so if I had just started with, okay, C2 is equal to this, I'd be really tempted to call that my constant term, but it's not. That's my C2. That's actually going to be the thing in front of x squared. And the C3 being 0, that's actually the thing in front of x cubed. So if I write down what I know about each of these, I don't know anything about C0, so I'll just leave it as C0 for now. I don't know anything about C1, so I'll leave it as C1 for now. C2 we actually know, it's negative 1/2 C0. C3 we know, it's 0. C4 we know, it's positive 1 over 4 times 2 C0, and that's multiplied by x to the fourth. I can't forget the x to the fourth. That's an easy mistake to make, is to just say, oh, C0 plus C1 plus this plus this plus this without remembering the powers of x. Next up is our x to the fifth, which would be 0x to the fifth. Our x to the fifth, which I'll write as minus 3 times 1 over 642 C0 x to the sixth. And I'm running out of room on my page, so I'm just going to put plus dot dot dot. Even though I did come up with 2 more terms, I think that's all I'm going to fit on this particular piece of paper. Okay, again, you keep going until you start to see the pattern. And we talked about in the last video that we do kind of start to see the pattern. We have a 2, 4 times 2, 6 times 4 times 2, alternating signs, and so on. Okay, so first of all, the zeros are just not going to show up at all. And second of all of these terms have either a C0 or a C1. And so why don't I split those up as the C0 parts and the C1 parts. So I'll write this as C0 times, that's C0 times 1. This is C0 times negative 1/2 x squared. This is C0 times positive 1 over 4 times 2 x to the fourth. This is C0 times negative 3 times 1 over 6 times 4 times 2 x to the sixth. And we said it's an alternating sign, so plus, minus, and then we would have plus, minus, dot, dot, dot. And so that's all the things that were underlined, all the C0 terms. And then we have plus our C1 terms, and there's really only one C1 term, which is C1 times x. Okay, so this should start to look familiar to you because C0 times a function is actually like having a C0 times this whole thing being my y1 plus C1 times this thing in the second brackets being my y2. And that's the way we're used to seeing a general solution of a second order differential equation. It's got 2 derivatives, it should have 2 constants, and so it looks like C0 y1 plus C1 y2. Or if we wanted to, we could go back and rename these C1 y1 and C2 y2. If someone asks us for 2 particular solutions, then great. We know the 2 particular solutions. Y1 is the thing in the first brackets, 1 minus 1/2 x squared plus 1 over 4 times 2 x to the fourth minus 3 times 1 over 6 times 4 times 2 x to the sixth plus minus dot dot dot. And y2 is the function in the second brackets, which is just x. So if someone asks us for the general solution, that's this guy. If someone asks us for two particular solutions, there they are. Yeah, so in this particular example, all the even powers of x ended up being related to C0. All the odd powers of x were zeros except for C1 x to the first, which ends up being our second term. That happens pretty regularly, that you have odds are related, evens are related, or you have something weird happening for your first couple of terms. That also can happen. So keep an eye out for those. Let's see. Okay, if you look at this example in the book, they actually go a little bit further. They actually find a formula for this series. I'm not going to bother with that. I'm not that worried about that. I'm more interested in, can you see the pattern? Can you come up with the first so many terms? So if I asked as part of the question, find the first 4 non-zero terms of the solution. Well, we have 1, 2, 3, 4 non-zero terms, so these are the 4 that we need. This one only has 1 term, so we've given the entirety of the solution. If I'd asked you find the first 5 non-zero terms, then we would just say, oh, okay, luckily we see the pattern. The next term would be a positive, is the 5 times 3 times 1, 8 times 6 times 4 times 2. More likely, I would ask you to find either 3 or 4 non-zero terms. I wouldn't ask you for any more than that.